Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have t to the power of 6 is equals to 4 to the power of 6, and we solve this problem for all the values of a and for the values of t. So here first we rewrite this equation as in this form. We write t to the power of 6 as t cubed and its whole square is equals to, this is 4 to the power of 6, and we write it as 4 cubed and its whole square. And now further in the next step, we move the term from right hand side to the left hand side, and we get 4t cubed and its whole square minus 4 cubed and its whole square is equals to 0. And now here further in the next step, we use the nice algebraic formula. You know about that. If we have a square minus b square is equals to a minus b times of a plus b. So according to this formula, we expand the left hand side of the above equation as this is t cubed minus 4 cubed into t cubed plus 4 cubed, and this whole equation is equals to 0. And now we divide this into the two cases. The first case is we write t cubed minus 4 cubed equals to 0, and the second case is we write t cubed plus 4 cubed is equals to 0. So we call this is our equation number 1 and this is our equation number 2. So we need to solve both of these two equations for the values of t. So in equation number 1, we apply here this nice cubic formula. If we have a cubed minus b cubed equals to a minus b times of a square plus ab plus b square. According to this cubic formula, we expand the left hand side of the above equation as so we write it as t minus 4 times of t square plus t times of 4 plus 4 square, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write t minus 4 is equals to 0, and the second case is we write t square plus 4t plus 4 square is equals to 0. From here we easily get the value of t is equals to 4. This is the first root of the given equation, and from here we get t square plus 4t plus 4 square becomes 16, and this whole equation is equals to 0. So here we need to find the values of t from this quadratic equation, and here we use the quadratic formula to solve this equation. And for this, first we write the coefficients of this equation, and its coefficients are a is equals to 1, b equals to 4, and c is equals to 16. And we state the quadratic formula as t is equals to minus b plus minus square root of b square minus 4 times of AC divided by 2 times of A. This is our quadratic formula, and here we substitute all the values of A, B and C, and this will become, this is minus B. The value of B is minus 4 plus minus square root of B square. It is 4 square minus 4 times of A is 1, and C is 16, and it is divided by 2 times of A, and here our A is equals to 1. And now further in the next step, we need more simplifications here, and we get minus 4 plus minus square root of 4 square, and 4 square becomes 16 minus, this is 4 times of 16, and it is divided by 2 times of 1 equals to 2. So here we need more simplifications, and we focus inside the square root sign, and we get t is equals to minus 4 plus minus. Here we take common 16 from the square root sign, and we get 16 times of 1 minus 4, and it is divided by 2. So here we apply square root separately on both of these two values, and you know that the square root of 16 becomes 4 into this is 1 minus 4 becomes minus 3, and further we break this fraction and we write this 2 separately on both of these two values. And now we cancel this term. 2 times 2 becomes 4, and we get minus 2 plus minus, this is also 2 times 2 becomes 4, and we get 2 times of square root of 3. You know that when negative sign appears inside the square root sign, it will become here iota. These are the other two complex roots of the given equation. So from equation number 1 we get these are the three roots of the given equation. And now in the next step here we need to solve our equation number 2. So here in equation number 2 we apply here this nice cubic formula. If we have a cubed plus b cubed equals to a plus b times of a square minus ab plus b square. So in equation number 2 we apply this cubic formula. So after applying this cubic formula into the equation number 2, this will be written as t plus 4 times of t square minus t times of 4 plus 4 square, and this whole equation is equals to 0. And here we again divide this into the two cases. The first is we write t plus 4 equals to 0, and the second case is we write t square minus 4t plus 16 is equals to 0. So from here we get the value of t is equals to minus 4. So this is the fourth root of the given equation, and in order to get the other roots, we solve this quadratic equation. So here we write the coefficients of this equation, and its coefficients are a is equals to 1, b is equals to minus 4, and c is equals to 16. And we state the quadratic formula as t is equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. This is the our quadratic formula, and here we substitute all the values of a, b, and c, and this will becomes minus b. The value of b is minus 4 plus minus square root of minus 4 square minus 4 times of a is 1 and c is 16, and it is divided by 2 times of a, and here our a is equals to 1. So further in the next step we have t is equals to, this is minus term minus becomes plus 4 plus minus square root of minus 4 square becomes 16 minus 4 times of 16, and it is divided by 2. So in the next step we have, this is 4 plus minus, here we again take common 16 inside the square root sign, and we get the remaining values are 1 minus 4, and it is divided by 2. So further again we focus inside the square root sign, and we get t is equals to 4 plus minus. Again you see that square root of 16 becomes 4 into 1 minus 4 becomes square root of minus 3, and it is divided by 2. And here we break this fraction and we write it as 4 divided by 2 plus minus 4 times of square root of 3. We know that when negative sign appears inside the square root sign, this will becomes iota, and it is divided by 2. So we need to cancel these terms, and we get 2 times 2 becomes 4, and 2 times 2 is also becomes here 4, and we get t is equals to 2 plus minus 2 times of square root of 3 into iota. So these are the other two complex roots of the given equation, which we get here from second case. So from second case we again get the three roots are in which these two roots are complex, and this is the one real root of the given equation. So from both of these equations we get three roots, and we total get 4 roots of the given equation. And this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.